Good evening, everyone, and welcome to UCLA. My name is Jean-Luc Margot, and I'm the chair of the Department of Earth, Planetary, and Space Sciences. Our mission is to understand and protect our home in the universe. And I'm very happy that so many of you are here this evening to hear one of our annual faculty lectures. There are about 27 faculty members in our department, so we have a while. We have some material for you before we have to start doing reruns. We're very excited about this evening's presentation because it celebrates the upcoming anniversary of a truly impactful moment in the history of the human race. The first time that we left our planet and set foot on another celestial world. If you think about it, it was daring, it was frightening, it was exhilarating, all at the same time. So I thought maybe we could come up with a new global calendar where day one is the day we left our planet and set foot on another celestial body. In our department, we study these celestial bodies and Earth in part because we want to understand how they form and how they evolve. These are fascinating questions. And also we like to compare and contrast the properties of these other bodies and Earth to gain a better understanding of Earth. And you can see that our alumni have played some key roles in these endeavors, and we're very proud of them. In our department, we like to provide hands-on experience and opportunities for memorable learning experiences. Our speaker, today's speaker, is shown here. He took his class to Meteor Crater in Arizona, where they could study the cratering process and other geological processes that shape the surfaces of our planet and other planets. They also had an opportunity to look for meteorites around the crater, and I hope that some of you saw the meteorites outside. If you didn't get a chance to see the meteorites outside, we have a phenomenal collection here at UCLA with some very nice specimens on display in the meteorite gallery in the geology building, and that's free and open to the public. It's open every day of the week from 9 to 4. So I encourage you to come and visit. We're very excited about this evening's event, in part because it is very well aligned with our mission of education and public outreach. And in the past year, our department has touched about 20,000 curious minds with a variety of events, including this one. If you go to our website, you'll see there's an outreach section, and you can find a list of our events, and you can also request an outreach visit to your school or organization if you wish. We're very passionate about the science we do, but we are equally eager to share the knowledge that we gain with a broad audience. If you believe in our mission of education, research, and outreach, you can partner with us and you can make a real difference, even at a small level. You can make a real difference in the student experience and the quality of the programs we can offer. So here are some of the initiatives that we are thrilled to partner with you on. One of the initiatives that's one of our priorities is to fund graduate student fellowships. And in particular, we'd like to honor Professor Margaret Kivelson with a fellowship name in her honor. She's a phenomenal role model for everyone in science. And she recently earned the Royal Astronomical Society's Gold Medal, which is that society's highest honor that was bestowed also on Albert Einstein, Stephen Hawking, etc. So Margie's in very good company. She's here in the audience today. Where's Margie? She's over there. Congratulations. If you're interested in partnering with us, I want to let you know that UCLA has a pretty extraordinary deal right now where they will match for qualifying gifts one-to-one. So if you're interested in partnering with us, please talk to us and we'll tell you all about that program. I would like to introduce today's speaker. He is a true Bruin. He got his bachelor's degree in our department in geophysics and space physics, after which he got a PhD at a small school across town. He was then a tech advisor for Star Trek, at which point UCLA realized that they really wanted him here on the faculty. And he's had a remarkably successful career here at UCLA, remarkable involvement with NASA missions, which has brought considerable visibility to UCLA. So he's the principal investigator of the Diviner instrument on NASA's Lunar Reconnaissance orbiter, and has produced a steady stream of high-impact results. He's also the deputy principal investigator of the radar imager for Mars subsurface experiment, an instrument that's going to be launching to Mars and on the next major rover to Mars, Mars 2020. He's received many accolades, including the NASA Exceptional Scientific Achievement Medal. So he's well qualified to talk about the moon today. He's also has expertise in other celestial bodies like Mercury. He was on the Messenger mission, Mars, etc., etc. So we will have a question and answer period after the talk. If you have questions for a speaker, please write them down on index cards. I believe volunteers are passing these index cards around. We will collect them, and we will use them at the start of the question and answer period. So thank you, and please join me in welcoming Professor David Paige.
All right, we're going to go through the usual mess around with the pictures and the slides segment of our evening. Yay! All right, well, thank you very much, Jean-Luc. That was a really nice introduction. In fact, you stole already half my thunder. No, seriously. And thank you all coming out tonight. And supporting a department as well as UCLA. This kind of event where a supposedly learned speaker gives a talk in front of a live audience showing slides and stuff is really old-fashioned, okay? In today's world, if you were, actually interested in learning about Apollo, you could just, type it into your web browser and get a bunch of links and start looking at them. And if, you liked what you saw, you could keep watching, you could flip to another one and, develop a pretty good interest in this. And it's fun, in preparing this talk, that's exactly what I did. I went online and said, wow, this is really interesting, learning as much as I possibly could about the topic. And I was delighted when I got the opportunity when Jean-Luc told me that it's time to do it. The live audience part, of course, is part of the experience because if you just sit in your bedroom and watch something on YouTube or something like that, you don't have the interactivity that occurs between the people in the audience and the speaker, and and the ability to ask questions and complain directly if you don't like what you heard, or applaud loudly if you like what you heard. And so in that respect, it is kind of a fun sort of social experience. So we'll try to make it fun and interesting for you as well, in the best spirit of a live performance. So when I came up with this title, Exploring the Moon Then and Now, basically deals with the issue that we're coming up on the 50th anniversary of the Apollo 11 moon landings this summer. And, as someone who was alive during the landings, and I'm sure this is true of many of you that were alive during the landings. Who was alive during the landings? Let's just get a, whoa! Okay, I assume the rest have not been alive during the landings. All right. My first reaction, and it probably was yours, was, holy moly, I cannot believe my time on Earth has gone by so quickly. That's at least what I thought. Can it really have been 50 years since this happened. But then you realize that, for a lot of people that weren't born before the moon landings, that the situation might be very different. And when you show someone a picture like this of an astronaut standing on the surface of another body, it just seems so foreign to your understanding. It just takes a little while to think about it. And the other part, of course, is if you Google the moon landings, you don't have to go pretty far down the list until you find some guy who's got a website or a YouTube channel where he says, I'm Joe, I'm really cool, and I'm really cool because I really think the moon landings were fake or something like that. and it's really an interesting thing. So I hope we don't have too many internet trolls in the audience. I would guess in a place like UCLA, they're probably few and far between, but that's cool. Because we're inclusive here. But we're also educational. and part of education is self-education. When you pick a topic like then and now, you're essentially signing yourself up to talk about history. And I am not a historian. I teach here at UCLA about science. So in a sense, I'm pretending to be a historian. Although I did myself live through the entire Apollo period, basically, and I had, a reasonably decent idea of what was going on around me at the time, I realized that there are a lot of things that went on then that I sort of never really sort of cleared up in my mind. And this was my opportunity, that Jean-Luc gave me this opportunity to speak to, go through some of those processes that we all have to go through as we get older and reinterpret events that we saw in the light of, in the context of experience and greater knowledge. And so it helped me sort of connect the dots in my life to some extent, which was, I think, very fun. Now, the other thing I learned about history is that there's not just one version of history. It's not like the Bible where there's like, one truth and you're going to learn it and, there you go. Each historian actually, as it turns out, comes up with their own account of history. And this could have different purposes. In some cases, they may have a goal of pushing their own perspective on things. I would never do that to you guys tonight. But or they might leave out, large blocks of information or people that used to exist, etc. And it's funny. And as I went through it more and more, I realized that basically all historians are trying are pretending they're historians at some level. And that's sort of fun as well. So what you'll get here is a kind of, condensed, personalized account of the Apollo era and the current era, then and now. But if you don't like it, just go on YouTube and get your own version or make your own version up. That's great. So one of the things I learned was that if you give a talk like this, it's very important to give an outline so that the audience has some, general clue as to where you're going with things. And I'll do that for you now and also sort of give away a lot of what I'm going to say, but you may feel interesting enough to see why I say some of these things to actually listen to the end of the talk. So here's the outline for my talk. So the first part deals with what are the unique historical factors that made the Apollo landings possible? And my main points here was A, von Braun, and B, the Cold War. And then second, how did the Apollo landings affect the world? And first I'll talk about the overview effect, and then I'll talk about the dissolution of the Soviet Union ? Next, the question is, why haven't we gone back to the moon since Apollo? And the answer is actually we are there now, actually. And then finally, what might the future of lunar exploration look like? And the answer there is economics and politics will decide. So we'll start our journey here. The Apollo missions came out to a very unique set of historical factors. And one factor really had to be the people that were involved, because it was people that did the Apollo missions. And the people who did this were part of a generation that historian Tom Brokaw referred to as the so-called greatest generation. Now, it's not that these people were just intrinsically great, okay, right out of the womb, but the events that shaped them led them to be able to collectively somehow do things that were great. And the idea is these were people who were born, sort of in the 1920s. They grew up during the Great Depression, periods of, where thrift and tenaciousness were important. They fought World War II. Many of them died. But they emerged from the war, produced an era of peace and prosperity that was, until that time, unknown. So one thing I realized was my mom was actually one of these greatest generations. I never really kind of made that connection before. Here she is, grown up in a small town in Minnesota, where she eventually, when the war started, got a job working for the War Department. In this case, she worked at the PX at a place called I got to get this name right, because there's a lot of weird names in this talk. The Fort Snelling War Department housed Military Intelligence Service Language School. This is where they would train people to be able to interpret communications and develop the language schools so that we could win the war. And that's the story. And the war, for many of the people that lived during that period, was a defining moment in that basically every able-bodied person in the country was somehow contributing to the war effort in one way or another. And while, of course, the war itself was terrible, the fact that the things that the people that came out of the war were able to do were truly amazing. So my mom is 96 years old. She's in the front row. You want to stand up? Let's hear it for the seal. All right. So when my mom was helping fight the war back on the home front, one of her most formidable enemies was this guy, Baron Werner Magnus Maximilian von Braun, shown here. He was born into an obviously aristocratic family. His mom bought him a telescope when he was a young kid, and he became totally fascinated with the concept of rocketry. Rocketry was a real thing back in Germany during those days. They had been soundly defeated during World War I, but still a lot of kids in those days dreamed of rockets. There were authors and clubs that formed all around the world, really, where amateur rocketry was a big deal. There was also an interesting technicality in the Treaty of Versailles at the end of World War I, which was very oppressive to the Germans, that basically prohibited them from developing any type of serious weaponry. And there was a whole list of forbidden weapons that could be developed by the Germans during this period, but for some reason, rockets weren't on that list. And so von Braun, who was basically a rocketry whiz kid, and was, decided to go into, got his degrees and did a lot of rocketry, quickly caught the eye of the military, the emerging military in Germany, and at the amazingly young age of like 21 years old, was basically, invited by the military to head Germany's rocket program. And his PhD was also in rocketry. in fact, it was on the topic of liquid fuel rockets. His thesis continued to be a state secret until 1960. That's how powerful his work was in engineering how to do liquid fuel rockets. So von Braun was, of course, a very capable person. In fact, the people that worked with him basically worshipped him his whole life. And he was, often described as one in a million. He could do the job of 10 people, they said. And not that he worked 10 times as hard as anybody, but he could easily insert himself exactly where it was needed within his organization to achieve maximal results. At one level, he could do the work. He could actually get down there and design the actual rockets and be a very, very competent, detailed technical engineer. He could also manage people. Since he knew how to do it himself, he could also get them to do that work as well. But he was also a manager. He could, a master designer. He could, come up with an idea for a new rocket, not just one that someone told him to build. And then he was also an architect. He could come up with, systems of rockets and ways to do the whole process of rocketry pretty much all on his own. And he was also a great diplomat. He could talk to important people, get them to get the support and facilities that he needed to do his work. And so he was a visionary, and he didn't simply just manage, he led. Now, his dream was to, of course, achieve a goal that had not been achieved until that time, which was to go into outer space. He himself personally believed he would get one day, as many people who were involved in Apollo, I might add, believed that they might get to go into outer space themselves. And the trouble is, of course, to do this, he needed to make a deal with the devil, who are these guys surrounding him here. These are officers, important officers of the SS. At an early age, he was asked to join the Communist Party and then become a member of the SS. And you can imagine the situation that von Braun found himself in, because if you were someone as valuable as he was in that time, and someone from that organization told you, we'd really like you to join our group, okay, it was pretty much an offer you couldn't refuse. And you can kind of see in this photo here, I'm going to try to show a lot of interesting photos to you. This is not quite Ken Burns, but there's a little of that mixed in here. You can kind of see the tension in this group here. Von Braun is clearly trying to show himself as not exactly part of this crowd of people behind him there. Even though they're sort of looking at him saying, hey, come on, whatever. And so he did own an SS uniform, and he did wear it, at certain times. There are photos of him in that particular position. But it was pretty clear that, at least, from historical accounts and interviews with people, that, he wasn't 100% on board with the whole Nazi thing. In fact, some evidence of this is that he spent time in jail while he was directing the rocket program for the Nazis. Apparently, he went to a dinner party one night and mentioned rather casually that he thought, the war really isn't going that well, guys. There's, of course, many standards for political correctness in different cultures. And in the SS, that was the most politically incorrect thing you could possibly say. He was, ratted on basically by someone that was at the party and got thrown in jail for a period of 2 weeks. It was tense, and they were concerned that he might just leave and defect, and it was kind of an interesting situation. So here's a picture of Peenemünde. This is a V2 rocket launching. This rocket was the first rocket to reach outer space. It wasn't capable of orbiting the Earth, but it was capable of traversing significant distances and had reasonable capability to target particular areas. But Peenemünde was not simply research and development, where you might have created, a few rockets and tested them and improved them over time. At Peenemünde, they launched a staggering total of 3,000 rockets during the 2 years that they were in operation. If you work that out, that's like 10 rockets a day. They were just shooting these things off like crazy, targeting places such as London and Antwerp, and causing very significant damage. It's estimated that on the order of 9,000 people were killed by V2 rockets. They were not the best weapons you could possibly have in those days. And people wonder, why did they then do this program? Well, there were two reasons. One was, first of all, it was cool, and it was inspiring that Germany could strike, at such a distance. That as the students who take my energy EPSS 101 course, we teach a course in energy as part of what we do in our department. They learn that, at least based on me, the amateur historian, that a lot of the strategy of World War II can be really traced to the availability of fossil fuels, because this is what would fuel a war effort in those days. And people needed gas to drive their cars and tanks, and most importantly, high-octane gas to fuel aircraft engines. And Germany didn't have those kind of resources, especially towards the end of the war. And so these V2 rockets were one of the few things they could actually really do and keep the whole thing going. The rocket itself was fueled by a mixture of liquid oxygen and alcohol. The alcohol was derived by distilling potatoes. And so these rockets were literally fueled by potatoes, which were actually in pretty short supply. The other very, very sad thing about this whole effort, and it would come to haunt von Braun throughout the rest of his career, is that if you really calculate it out, more people died actually building these rockets than were killed by them on the other side. The SS set up basically labor camps that were actually put underground to protect from Allied bombing, and it's estimated that on the order of 20,000 captives were killed in the process of building this set of bombs, this set of rockets as well. So again, a very regrettable story. Well, the Germans lost, and here we have a picture of Wernher von Braun just after capture. And you can see on the face of this man the anguish that someone in his position would feel. His life work ruined, his country defeated, captured by the enemy, and with a broken arm to boot. Of course, his expression couldn't be more happy. And this is for two reasons. One was that he was actually involved in a rather desperate struggle to escape from his Nazi friends. He was well known to Hitler, as one of the most important and valuable people in the entire country. And as things were collapsing, he had basically set out orders to, I want you to keep this guy under arrest, basically. And if there's any chance we, don't get defeated, I want him back with me working. But if they come to get him, kill him. And that's exactly the sort of situation he was in. But he managed, along with a bunch of his close associates, to slip away from them over the border to Austria. And so he managed to make it to Austria, and he was captured by the Americans. And so the fact that he was alive, of course, was a plus, but also he also knew that given the superior resources of the Americans and their general attitude about these things that he really was going to get his chance to go to the moon. And it pretty much came true. A whole bunch of Nazis, as well as their equipment, was shipped to the United States. Initially, they were kind of kept, in jail and had to, work on the rockets under this circumstance. But pretty soon, it became clear that they really were kind of, behind our program. Their Nazi past was expunged. Don't ask me how you do that, but it was done. And then, in the normal course of events, given how brilliant von Braun was, he quickly found himself at more or less the forefront of the U.S. space program. And here's a picture of a very, very significant picture to those in our field for a number of reasons. On top is Explorer 1, the first successful orbiting satellite that was launched by the United States. Very important. On it was a Geiger counter that was designed by James Van Allen, who was the person responsible for the discovery of now called the Van Allen radiation belts around the Earth. This was the first instrument that was ever put on a satellite, okay, a successful instrument that was put on a satellite. It marks the beginning of the field of space physics, essentially. And then to either side, we see William Pickering, who was the director of JPL, the Jet Propulsion Laboratory in Pasadena. And this, of course, is their start pretty much as well. And then here we have von Braun, who is from the Army Ballistic Missile Agency, as it was called in those days. And this concept of a partnership between, industry, academia, and government, which sort of, characterizes the space in our world today, at least it should, was born. Now, those of us that are involved in these missions notice that things really aren't like this anymore, okay? And there's two aspects of it that are different. And one, the spacecraft we use are so gigantic that it's impossible for the three principal people to hold it over their heads like this. They would be smashed, okay? And secondly, they never let the scientist guy go in the middle. But at UCLA, we're actually in the process of rebirth of this phenomenon, and I show you our own Vasilis Angelopoulos, Professor Vasilis Angelopoulos, with two models of his Elfin CubeSat spacecraft. These were designed and built by a team of students and launched last year and are in orbit around the Earth acquiring new data in the field of space physics. So we can do it ourselves, to heck with the rest of the world. Back to von Braun. So von Braun, was definitely a key technical and player in the whole rocket business, but he was actually doing a lot more all this time. He realized that in order to, in the way our system works here, public opinion is a very important factor in terms of, how things go. And he worked very, very diligently with a variety of different types of artists, designers, and I dare say propagandists to create this general concept in people's minds that we were destined to go into space. Here he's shown here with Walt Disney, who had a very analogous or similar sort of concept. Space was just one of Disney's ideas. He had, if you go to Disneyland, especially in the old days, there's this whole world of tomorrow, Epcot Center kind of concept where, we're going to live in this futuristic world. I mean, I grew up during these times thinking I would have a flying car by now, for sure. I mean, there was just no question about that. And von Braun really worked with the best to get these ideas out there in the public as well. And one great example of this that just connected with me as I was looking at the whole history of it from this perspective was the storybooks that are read to kids. So if you have kids recently or were recently a kid, you all, of course, know about this book. It's Goodnight Moon. It's about a sleepy rabbit and who has to say goodnight to the moon, and it's great. And it's a great, wonderful book. We read it to our kids, but it was written or published in 1991. This was way after I came on the scene. So the book I got when I was a kid was this one. You Will Go to the Moon. This book is basically a space architecture manual for a six-year-old reading level, okay? It talks about, first we're going to build the space station, then we're going to go. It's just right out of von Braun's mouth, okay? And the illustrations and all this kind of stuff, it's just crazy. And I think my mom probably read this to me every night. It was my favorite book. And so it's no accident that so many of us had this dream of space travel. In fact, when I look at the title right now, I can almost think that, it's, what? I can almost hear that I'm being, screamed at by, it's all caps, you will go to the moon. It's almost like it's like orders. It's interesting when you look at it from that perspective. And a lot of us really liked it and bought into this dream. So von Braun did realize his dream as well. He was the person who was primarily responsible for building the Saturn V rocket, which was the rocket that carried the Apollo astronauts to the moon. Here he is seen here with it. This rocket, still today, is the tallest, heaviest, and most powerful rocket that has ever been put into actual operation. And of course, it was the enabling thing for the U.S. Apollo program. But we know that rockets are mostly a weapon of war. And the question that comes up when you see this is, what possible foe could warrant us spending so much effort to build such a gigantic rocket? And I have the answer. So, what's this? Younger people might say, oh, these kids are doing their biannual active shooter training. And I'm sorry, that's not a very good joke. but that's not what it is. It wasn't active shooters terrorizing our kids we were worried about. It was basically nuclear annihilation. We had to basically, when we saw the flash, right, we were supposed to immediately get under our desks and cover ourselves up, put our knees, heads between our knees, and then also put our collars up over our necks, and then put our hands over the collars, and they had this whole prescription exactly how we would, survive a nuclear attack. And we did this a lot during the Cuban Missile Crisis. I remember this as a first grader, and it was interesting. So when I was in first grade, I wasn't really that great a student, actually, but I did know a lot somehow, and I listened to the radio a lot. My parents always had the news on TV, on the radio, and I actually knew the names of all the people in the cabinet, all the major leaders of the world. I don't know how I knew this, but these names sort of got stuck in my mind. And even as a little kid, I knew exactly who was trying to kill me. Okay. It's this guy right here, Nikita Khrushchev, the head of the Union of Soviet Socialist Republics. And I also knew that the only guy that could save me from this guy was this guy, John F. Kennedy, the dynamic leader of the free world. So this is how it was sort of put to us as we were kids. And of course, as I got older, I learned more and more about what was going on here and why the Russians were apparently trying to kill us. And what I found out was this wasn't just like a regular war in the sense that people are either there was some personal animosity between Khrushchev or Kennedy, or there was some particular territory or nationalistic aspiration that was dealing with. This was a war between two completely different ideologies and economic systems of organization. Now, on one hand, you had the USSR, which stood for socialism. And in socialism, they advocate an ideal means of situation in which 100% of all production and distribution of all the goods and services are owned and regulated by the community as a whole, rather than private individuals. Now, in the ideal socialist system, you end up something with like Star Trek. In the world of Star Trek, Captain Kirk and his group of ethnically and something else diverse crew go around the galaxy converting new aliens to the Federation, and everyone gets along great. There's no need for money or anything like that. Now, in Kennedy's capitalistic system, it's the opposite. The situation is that the means of production, distribution, except are done by private individuals through a competitive system. And if you have trouble sort of understanding that system and want a better analogy, that's Batman, where millionaire philanthropist Bruce Wayne is able to protect Gotham City, and anyway, so that's the story. And this was a global conflict that had very huge ramifications all up and down the globe, because each of these different groups was basically trying to convince client states that their approach was going to be the best one possible. And there's no real reconciliation if you completely polarize these two things. There's no place for Batman in a Star Trek world, and there's no place for Star Trek in a Batman world. And it was a war both of, and because of the significant destructive power that exists, a lot of the war had to do with soft power. One of the biggest issues for soft power was, of course, things going on in space. And this was an area that, in the early part of the so-called space race, the Russians were killing us. First, they set up Sputnik in 1957. Then they set up Laika the dog in 57 right afterwards. And then they sent up Yuri Gagarin, the first man in space, at least to orbit the Earth and make it back alive in 1957. What, did I get that right? 61. Oh, sorry, right. In 1961. History has shown there may have been other cosmonauts before Yuri Gagarin, actually, who went up in space but did not make it back alive. Okay, that's completely believable. But Gagarin is credited with the return trip. Meanwhile, while this was going on, and of course, the Soviets were just like in your face about this, okay? Like Khrushchev was very, very good at saying, this proves that, we are the best people. He also was going to get the first woman in space. They had so many firsts, it was like crazy. In the meantime, we were messing up big time. This is the description of the Daily Herald of the launch or attempted launch of the Vanguard rocket in 1957. This was televised live on national TV. The rocket went up about 2 feet and then went down and exploded in incredible conflagration. America's Sputnik dies bleeping on the ground. I just love that. Anyway, we weren't doing very well. And the problem is that, it was really, really embarrassing for us. And so we needed a way to somehow immediately, not just, long term, but immediately show that we were on top. And the administration cast about for an idea, and what emerged was that we would basically claim that we would make it to the moon by the end of the decade. And here's a great newspaper headline that describes the point of the speech. It wasn't that, boasting like, oh yeah, we're going to beat you to the moon. It says, we're going to win. It says we must do this. And the fact we're even trying to do this, somehow makes us superior. And that is how the original, with input from senior advisors, including von Braun, this was something that they believed they could do. But the methods and means by which this was done at this time were completely unknown for us. It was just a shot in the dark. It was almost as if I were to say, we're going to send a spacecraft to Alpha Centauri by the end of the decade. I mean, that's about how crazy sending a man or men to the moon at that time particularly was. I found this picture here. A lot of, as we're approaching the 50th anniversary, a lot of really interesting photos that haven't ever surfaced before are coming out. And I found this one, and I found it so interesting and fascinating for so many reasons. So what we have here is an early meeting at the Launch Complex 34 in Cape Canaveral. Over here is James Webb, Director of the Manned Space, Lyndon Johnson, the Vice President of the United States, President of the Space Council, Max Debris, a Nazi, John F. Kennedy, former Nazi, sorry, John F. Kennedy, President of the United States, Davis, who was the head of the Strategic Air Command, Robert McNamara, the Secretary of Defense, all sitting there. I also couldn't help but notice another guy lurking in the back there. Does anybody see that guy? Do you see him? Does anyone see him? He's right there. Okay, now this is a generational thing. How many people have seen this movie? Okay, all the old people. Okay. Young people should see it. This was an extremely influential movie, but I had no idea the degree to which it was actually, based on a snapshot of what the world was like at the time it was being made. It's just incredible when you look at it. Now, it's called Dr. Strangelove, in case you want to Google it. All right. But those of us who have experience with the geology building at UCLA, okay, who maybe were alums long ago or were at there long ago, or even people there presently, will notice that there's something about the interior decoration style of this whole launch complex that looks familiar to us, okay? So, do you notice the general color of everything here? Does this color bring back any, memories? A lot of our building has been painted, but at least when I was a student there, this color was pervasive. Look at this floor here. Look at that. Those tiles, they're actually made out of asbestos, as it turns out. But these asbestos tiles they have on the ground, the same sort of thing here. And look at the chair. Look at the chair that Kennedy and everyone else is sitting at. That's what those chairs that we have look like when they were new. And what happened, apparently, the government basically gave UCLA all this stuff. They built Slichter Hall, and with it came all this furniture and stuff like that. I know in my office, I've got a vintage set of really cool Cold War era bookshelves. They're made out of steel. This is stuff that's going to be really valuable someday, I can absolutely guarantee you, so don't steal it. So this here looks really militaristic. I hate to tell you, right? I mean, you probably can't get more hardcore than this group of people here, especially with Strangelove in the back. But the idea of the Apollo program was it was not going to be having the appearance of being a military program. Okay, it was a civilian space program that the American people could get behind, even if they didn't like what was going on militarily. And there were a lot of people like that around the world. So the whole concept of Apollo was that we would do it under the NASA banner, but essentially all the processes that would be used in terms of how the space program would actually work were essentially military. All the contractors that provided the equipment, the management structures, the whole thing was totally military. And we kind of, and obviously the astronauts themselves were military. They were all, test pilots or Navy pilots and stuff like that. And in our country, we take for granted how militaristic our space program actually is, but we don't even notice it. It's like, oh, yeah, of course, but when we work with people from foreign countries, like in Europe and stuff like that, it's a completely different sort of thing. There they have lots of give and take, and they ask people to do stuff. They don't just tell them to do stuff. There's the chain of command is much more, free and open. Here in the Apollo program, we're talking hardcore militaristic. And, these astronauts, they knew what they were getting into here. This was really, really risky stuff, getting on top. If you've ever actually seen a rocket in person and thought about how brave you'd need to be to actually get on top of that thing and fly up, it's just insane. And these guys knew they were getting into something and that, this was very dangerous and people would die. In fact, these 3 guys did die as the Apollo 1 astronauts. These were our number 1 crew of Apollo astronauts that died in a fire. And to a man, when they talk about their experiences as astronauts, the number 1 thing they say is, I was a Cold War warrior. That's what I was. I wasn't an explorer. I wasn't a scientist. I was beating the Russians. So the Cold War was tough on all the different countries. Back in the Soviet Union, they were competing with us in space. They were also working hard to provide the thing that the socialist system was found difficult, which was food and consumer goods. Here's Khrushchev with the corn and sewing some, motivational posters. On the United States side, we're having our problems too. We got involved in a war in Vietnam, which was nominally to stop the spread of communism, but there was a lot of people that were against it, especially due to the draft. And then there was a lot of actual social change during these times. There were long-standing issues involving discrimination and other things like that. And it was a time when many groups that hadn't had rights before started to earn them. It's interesting when you look at the situation here that the Russians also, the Soviets also really played the strife that was going on in the United States up in their propaganda. They said that essentially the issues we were having were fundamentally caused by the capitalistic system, and that if we'd only convert over to their system, none of these problems would happen, since everybody would get a paycheck and everything would be great. There was a period where we had this very significant effort to try to redress these issues called the War on Poverty. And historians today, we don't have one of those now, even though we still have poverty, but historians today look back on this and think that it could well be that the Cold War was a big factor in many of the efforts at the state level to deal with systematic poverty. So it's an interesting thing to think about. So in the end, we won. We got to the moon. The astronauts went there. They dug around in the soil. They planted the flag. They did all the things they were supposed to. We didn't lose anybody. And it was a huge success. Here's a great shot of an astronaut with his suit. If you ever happen to go to the Air and Space Museum, there they have on display one of their most important relics from the Apollo era are these spacesuits that the astronauts wore. And they take a good look at them. They don't tell you this in the plaque that's next to it, but they're covered with moon dust. That dirt that's on them is actual dust from the moon that came back with the suits that they never bothered to clean up. It's amazing. So lunar science was one component of the Apollo missions. Here's the same shot that was included on the lecture slide. You can see that if you maybe in the front row that there's different colored rocks and soils in the front here. This was one of the most important discoveries that was made by Apollo. There are some places here where there's glass, pyroclastic deposits due to volcanoes that were going off on the moon that we collected and brought back. Of course, the samples that were acquired by the astronauts in 6 places on the moon, this is a rock that Neil Armstrong picked up, are absolutely invaluable to us. It's the only planet that we've been able to study that we've got samples in 6 places that can use that to anchor all of our studies. The beauty of these samples is that they're a gift that keeps on giving. As techniques of analysis continue, we can learn more and more from these samples, and then all the data we get from the moon can be put together to make this edifice of knowledge. Do we have a display of the lunar meteorites after this? Oh, it was already, okay. Some of you got to see lunar meteorites, which we can now recognize in our meteor collection once we've seen what the actual lunar rocks look like, which is pretty cool. The science of planetary science moved forward tremendously during this period. In fact, this is the origin story of our entire field. We learned a lot about the moon, and the moon is very valuable because what we learned about it was it's a very ancient body. Most of the processes that shape the surface happened 3 or 4 billion years ago. Most of this information has been erased on the Earth, and so it's sort of like a time capsule that we can use to study early solar system processes. As we might talk about in the question and answer session, nobody had any clue really about what the moon was like before we actually went there and measured it. And we're still learning about issues involving its origin and evolution that can teach us a lot about how planets in our solar system beyond evolve. There was one super unexpected discovery. We expected to learn about the moon. Obviously, that was the whole focus of the Apollo program. People were studying the moon. Yes, we're going there, we're going to study the moon. But there was one huge unexpected discovery that the Apollo program gave us. And it seems really dumb in retrospect, but the thing that and that's probably distracting you right now, is this thing off on the horizon here. That thing is the Earth. The astronauts who are going to the moon were totally focused on the moon, beat the Russians, get the samples, do all the stuff they needed to do. But any sort of observation or consideration of what it might, looking back at the Earth wasn't part of the original plan. It just happened by accident in Apollo 8. I think they said, oh, let's turn the camera back. Oh, look, check out the Earth. And all of a sudden, my God, look at the Earth. I've never seen the Earth look like this before. And it's true, no one had really seen the Earth from that perspective before. People had hypothesized that if it were possible to see the whole Earth, that it might have a profound effect. And it certainly did. And there have been many books and poems and stuff written about this, and I can't be nearly as eloquent as all those people. But just to see the fragility of and beauty of the Earth, and then most importantly, the backdrop of space, the emptiness that it sits in, had a very profound on people that saw the pictures, and especially on the astronauts that went. And everybody who knew an astronaut before they went to the moon and then came back agreed that they were very different people from the experience. It's sometimes termed the so-called overview effect in popular culture today. And as with many historical events, it's very hard to really figure out exactly what the impact of any particular one factor might have been in terms of how history turned out. But you've got to believe that this view of Earth with no boundaries, no international boundaries, dynamic, and round and whole, probably did have a very significant effect. So, what happened after Apollo? Well, the day after Apollo, there was an article in Pravda, the state newspaper in the Soviet Union. The top front page article was about the benefits of collectivism. There was a small article at the bottom of the front page acknowledging that the Apollo 11 astronauts had landed on the moon, and commentary from various Russian space experts in a somewhat congratulatory tone, recognizing the challenges that must have been involved in such a great endeavor. But that was it. No pictures, nothing. Soon afterwards, this guy, Dr. Andrei Sakharov, who was a major figure in developing the Soviets' hydrogen bomb, who then became a dissident, basically wrote a letter, unsolicited letter back to the folks and said, if nothing else can convince you that our system sucks, this has got to be it. And he really got exiled and had all sorts of problems, but he was willing to basically say what everybody was thinking out loud, and that was the story. So that's what happened in the Soviet Union. Back here, things were also a little bit weird. Our local hero, Richard Nixon, Milhouse Nixon, had been elected president. He skillfully managed to manipulate longstanding divisions within the country to make it to president, and he was the president during the time that Apollo 11 landed. Here he is, very awkwardly greeting the 3 astronauts that were still in quarantine at the time on the USS Hornet once they were picked up by the Navy. But Nixon is important because it was left to him to basically decide where the country should go in terms of space after Apollo. And there were basically 2 camps. There was the von Braun camp, and his attitude, here he is flying around at 0G having a great time, said, well, hey, look, we made it to the moon. The next logical step is for us to go to Mars, of course. And he came up with a series of very interesting plans that involved basically moving a lot of stuff into orbit to stage the ultimate exploration of Mars, and actively pushed for this approach in Congress and other places like that. On the other hand, there was this, the space shuttle. The space shuttle was to be a joint program between NASA and the Department of Defense. It was a refuelable, reusable space plane that could fly out into orbit around the Earth and do all kinds of exciting things. It could take satellite, you could put a satellite in here and deploy it, and you could also go into space and grab another satellite and then put it back into the bay here, okay? And this was something that our Department of Defense was very, very interested in and really drove the space shuttle. Now, the space shuttle was nominally a civilian operation, but those in the know have told me that you should really watch this movie Moonraker, which was starring Roger Moore. I think it's known to be the absolute worst James Bond movie ever made. But they tell me that this, astronauts going to war with different space shuttles is something we should sort of pay attention to. Another thing happened, after Apollo, which has, to this day, pretty much defied complete explanation, which was the dissolution of the Soviet Union. It's something that just happened. And it's just not the right kind of talk to go into all the issues and things like that, but it was really a breathtaking thing. It happened with almost no significant violence. This is likely due to the fact that this guy, Mikhail Gorbachev, was basically a nice guy. He said, okay, I can see the inevitable. I'm not going to, use extreme tactics to keep this whole thing together. And all these, the whole union, basically, first it was the Estonians, then the Armenians. They said, we're not going to be part of this. And they just couldn't be stopped, and the whole thing just went away. How much Apollo had to do with that? It's really hard to say, but the inner, emotions and faith that people have in the system you're using are a key part of it, and certainly Apollo did a lot to damage that. So one topic that needs to be addressed is the money. And when you talk to people about space exploration, they often start talking about money and, this cost so much, and they'll pull out some figures and stuff like that. Here's one way of looking at Apollo. It shows, as a function of time, a graph of the percentage of the federal budget that went for civilian space exploration. We don't know how much is military, but this is the NASA part of it. And there was this huge bump here. At max, we were spending almost 5% of the federal budget on Apollo during the period it was being developed here. And then soon afterwards, it trickled away. And then ever since, we've been in this little area here where we're at sort of on the order of 0.5% or 1% as a function of time. And it is true, this was a very large amount of money that was spent. But it's always important when you look at any numbers to try to put them in perspective. Now, I had a lot of trouble in the amount of time I had to produce this talk to get some good numbers. So I'm using someone else's numbers that I found here. These were put together in 2008, which is a significant year, as we all know, that tries to show the total amount of money spent on various things that the government has spent money on. Here's the F-22 Raptor program up till 2008. This is the Apollo program in red here. This was the interest on the federal deficit in 2008. This is the interstate highway system, the entirety of it. This is the Vietnam War, the entirety of it. This was the financial bailout of 2000 in 2008. It was actually called the Emergency Economic Stabilization Act, where basically something like $700 billion was given to make whole some people that had made some bad investments. And then here is the spending up to 2008 on the Afghan and Iraq wars. If we were to project these numbers up until present time, we'd be way off the screen here, okay? So this idea that we don't have money to do space exploration really comes off rather hollow in this view. If in 1 year George Bush could just decide to create $700 billion just all of a sudden we need it, okay? We certainly could afford more Apollos, and this was the point that the guy who put this together was saying, that if you costed a return to the moon with humans, we could do it. Now, the question of, why should we do it is the issue. This is what drove the space shuttle decision, right? Because why should we go to Mars? The Russians couldn't even get to the moon. We're not racing anybody anymore. There's no point. At least that was the rationale that was used, independent of the other societal benefits or gain of knowledge. Now, since this time, we haven't had a real coherent lunar program, but we have had one amazingly successful lunar mission called the Lunar Reconnaissance Orbiter. This was launched in 2009, and it has managed to stay in orbit this entire time and continued functioning. this mission was intended to systematically map the moon in a way that had never been done during the Apollo era. Apollo was, we got to get to the moon, but the idea of mapping the whole moon and putting it into a remote sensing context and learning about the whole moon really wasn't that much of a part of the Apollo mission. The beauty of LRO is that we can use what we've learned with Apollo and then combine that with much more high-tech remote sensing capabilities that have been developed, for instance, for Mars, and then put together a much more detailed, nuanced view of the history of the moon. I'm the principal investigator of the Diviner Lunar Radiometer experiment. We built this and have flown it, and it's operating right at this very moment, out in space, moving around, looking at things, getting data back. It's basically on all the time. It's been on the entire time I've lived during the last 10 years, basically, gathering data. And because the moon is so close, the volume of data sets that we can acquire are absolutely enormous. Our data set is the second largest data set that has been collected in the field of planetary science, second only to the camera system on LRO, which has gotten more than us. And we collect and distribute and analyze this data right here at UCLA. The type of data we get from this is thermal emission measurements. We're basically measuring the temperature of the surface of the moon both day and night as we move along. You can do a huge amount of cool stuff with this. And when we originally proposed to build this instrument, we had a whole list of stuff that we had proposed to do with it. We did that like in the first year and a half. And everything we've done since then has been like new things that we had no idea we could even imagine doing. And what's so interesting about it is the work continues to get better and better. Our last big success was this, a publication in Science magazine last month. Our Canadian crew, which consists of Sarah and Rebecca, put together an amazing paper that tries to address a long-standing problem we've had in Earth science, which is that the Earth is too dynamic to record information from impacts over long periods of time. And so the moon, using it as a witness plate, sitting out there collecting impacts, with diviner data, we can very easily quantify how old all these features are based on how they fade, and then use that information to gain new insights into the history of the Earth. And the history period of the Earth that we're interested in is a very important one. It's basically the last billion years. This is the period of Earth history where basically all of the evolution of life has occurred. It's the part that basically gave rise to us. And sort of understanding its history is important. And this is a picture of impacts that have been preserved on Earth over time. This one here is the real big one, the one that wiped out the dinosaurs, the Chicxulub impact. But there's been many, many others that we can interpret. What was found in this study is that the rate of impacts on the Earth-Moon system, which are basically in the same part of space, was going along, and then something like 300 million years ago, the rate went up by a factor of 2.5. And it's verifiable when you look at the Earth data as well as the Moon data. Now, given that we know that it was an impact, and this was right when the dinosaurs started, not when the dinosaurs ended, okay? So this idea that the Earth and its evolution are sort of connected somehow to events in the solar system, the cosmos, is very profound. If I would have proposed, oh yes, we're going to track the history of impacts and make fundamental conclusions about the history of life on Earth when we proposed this, we would have never made it. But that's the beauty of having a successful instrument. You get to do a lot of great science you never thought of. LRO is not the only spacecraft orbiting the moon, operating on the moon right now. There's one other, or actually two other, and these are put up there by the Chinese. They have a mission called Chang'e 4 right now, and it is doing something that wasn't done or couldn't be done during the Apollo era, and that's exploring the far side of the moon. So the way it works is the moon orbits the Earth, but it always keeps one side to the Earth, so we always see that side. There's a back side of it we can never see. But there's a lot of exciting places there to explore. And so what they have done is put together a network of spacecraft that can enable this. There's a point here called the L2 point. They first sent an orbiter there that orbits this and constantly sees the back side of the moon and the Earth. And then they sent a lander to land on this backside, and then it relays information to these various assets back and forth. And there's also a small rover. The mission is targeted to the largest and oldest impact basin on the moon, the South Pole Aiken Basin, which was only discovered after Apollo. That's how little we knew about the backside of the moon, in a place called Von Karman Crater. Studies have suggested that sampling this area would probably be the most likely place to learn about the oldest history of the moon that we have not yet learned about. And this is exactly where they are and studying. Here's a panorama from that particular location. And you can see here what the terrain looks like, as well as this cute little rover, which I think is still called U2. Maybe someone who knows more can tell me, but I think it's still called U2, which has gone out and made measurements as well. And the next step in the Chinese space program will to actually be acquire samples robotically and then bring them back to Earth, maybe from remote, scientifically exciting stations like these. And I see Kevin McKeegan in the front row here going, yeah, I want this stuff. This is really, really exciting science. So it turns out that we're not allowed to collaborate with the Chinese. It's still something left over from the Cold War. There is actually laws against me calling up a colleague in China with NASA money and saying, hey, buddy, let's talk about science or come to my meeting. But there is, scientists being who they are, there's still interesting collaboration, but it's sort of the, when you have like little kids, when they're first starting to grow up, they call it independent play, where one kid sits here and then one kid sits there, and they both play independently, but there's some acknowledgement of the fact that there's another kid there. It's the first step. Well, we are doing independent play right now, and and one of the things we can do, which sounds a little Cold War-ish, but that's just the way it is we have this reconnaissance orbiter after all. We can actually spy on what the Chinese are doing. So here's a shot that if you, maybe you've been checking the news, if you're a moon aficionado, you have seen. It's a picture of Von Karman Crater. It's a huge, gigantic crater. Here's the rim of the crater, and here's the floor of it. Here's a more recent crater. This crater here is 4 kilometers in diameter, just to give you a rough scale. These tiny little arrows, maybe from the front row you can see, is the point at which the Chang'e 4 lander and rover are located. Now, you may ask, well, how did NASA, who's not supposed to talk to the Chinese, get a hold of the location of the Chang'e 4 rover? Well, it was very fun. The Chinese published a beautiful, and I'm not going to show it because there's no time, a beautiful time-lapse sequence that shows a movie camera, as it went on, as the lander descended down and then finally landed on the surface. It just looks like the Apollo movies, except it's Chinese. So all you need to do is find out where it is. We've got the best maps of the moon. All we do is look at the features that you can see at low resolution and then track them down, and we're able to find the exact spot to then look for the lander. And there it is. Now, it's a really pretty picture. It shows the setting of the moon, which is phenomenal. Look how cool it is. There's no atmosphere on the moon. You can't judge distances very well. And you have no idea how big anything is, based on its context. It just shows the cool vastness of the thing. This picture has been published. I have a super, super special treat for you. I called up the head of our project and the guy who's in charge of this camera at ASU, and I said, I know you've got another picture, okay, that's going to be published on Monday. Is there any way you could find it within your heart to let me show the other picture that nobody's seen before to this audience tonight? And there was a lot of hemming and hawing, and they said, okay, but whatever, please do not tell anybody you've seen this picture. So can I get an oath from you folks that if I show you this picture, you won't, oath of allegiance here, you will not take a picture of the picture or tell anybody I showed you the picture, right? Okay, thank you very much. Okay, here's the picture. Now, can anybody spot the lander? It's there. It's right in the middle. And can anybody spot the rover? It's that. Yeah. Here, I'm zooming in. There it is. The lander and the rover. You can see its solar panels. You can see its shadow. It's all right there. And for the skeptics, for the deniers, we've got pictures of all the other Apollo and the footprints of the astronauts and the tracks of the rovers. It's all there to be seen. Very, very exciting to be able to involve with this. Okay, I just have a few more slides. I know Jean-Luc is trying to get me off he's got the cane ready. But three more slides, if you don't mind. I knew this talk would probably go over. Bad people. Bad. Come on, the UCLA community. All right. Just don't show them until Monday, okay? What can we imagine happening as we go into the future here? Well, the future is very tough to predict, okay? Nobody predicted the dissolution of the Soviet Union. Who knows what crazy things could happen in the future based on current events. What we do see, though, are some key trends. And one really important one for the standpoint of future moon exploration is the cost of launching stuff into space. Now, when the space program first started, Vanguard being our vanguard in this respect, the cost of launching something into space was something like, $1 million per kilogram, okay? And then costs came down, obviously, because they were doing the original research and development necessary to figure out how to do this right from scratch. Costs came down very rapidly. The Saturn V, as it turned out, was a rather cost-effective vehicle, mostly just because of its sheer size, okay? Bigger is better in this respect. The space shuttle, this was billed as being a very, very cost-effective launch platform due to its usability, but in fact, it was terribly expensive, and this really set us back for a while. Costs then started going back down, but then a new player has emerged. SpaceX has the Falcon 9 and the Falcon 9 Heavy. This is a commercial company, and there are many others. There just happen to be on this graph here that are pioneering new approaches to reducing the cost of launching, and it's really starting to show. Now, you may ask, well, how can you possibly do that? Do they have some new magic technology that von Braun had not invented that somehow can magically put a rocket in space? The answer is no. All it is simply refinement of existing practice, but with the idea that we really, really want to do it cheaply. The issue is during this period when there was stagnant and no progress, the major customer for these launches was the military. They couldn't deal with failure or any sort of issue. And so, but now we're in a more commercial world, and the Falcon 9 and the Falcon 9 Heavy are breaking new ground in terms of cost. Reusability is key. This is the very impressive now, exactly 1-year-old dual landing of the Falcon Heavy test booster. SpaceX has now sold manifests that will allow them to launch commercial payloads on the Falcon 9 Heavy. And then almost amazingly, they are now developing the next generation, which is the Starship rocket. This was rolled out this year, this month. This is still a test rocket here. This is a man standing there. This rocket now is one that can truly rival the Saturn V and has truly interplanetary capabilities. SpaceX has found a billionaire who wants to fly around the moon, and their plan is to do it. Here's SpaceX CEO Elon Musk describing it. They're also developing a virtual reality system that'll let us all put on VR glasses and fly along with them back and forth to the moon. This is, I think, a very impressive development. I actually know Elon. He's a very impressive guy. He has a lot of the characteristics I might have imagined von Braun had. He has fascination with space. He's smart. He knows the technology. He's a good technical leader. He's got vision. He also wants money. And those are a very potent set of characteristics. And so far, he's done an absolutely fabulous job of pioneering into space. And we'll see where this actually takes us. So in conclusion, I want to say that, I've only really scratched the surface in terms of the history of the exploration of the moon. It's such an involved topic with all the history of people that were involved in it over the years, the science, the politics, the drama, all this kind of stuff. I haven't even gone into the issues about lunar resources, if there might be things on the moon that could make it actually economically viable to go there in the present day. Right now, it's basically for national prestige and tourism, and maybe a little bit of planting the flag, that eventually somebody might get to own this rock that orbits us here. And of course, the stark contrast. Here's a picture from the Japanese that show exactly properly exposed what the moon looks like relative to the Earth, and you see the huge difference in the evolution of these two planetary bodies. Exactly the same distance from the sun. Moon, lifeless, no atmosphere. The Earth crawling with life. Lots of exciting things going on. It's cool. And then I'll leave you with this last interesting question, is what are we really going to do with the moon here? Okay? Is it going to be a resource that we all share? In other words, if you look at, for instance, how countries like Norway have dealt with their natural resources, they basically divide them up between the populace and say everybody gets a share of it. These space resources are in the same boat, or are we going to let Elon Musk own the moon? And that is really the kind of question we need to ask ourselves as we move forward. So with that, I will get off the stage and turn it over to our question and answer period. But thank you very much.
Thank you. I will ask our panelists to come to the front, and we're going to have a short panel. We need to leave the space by 9 p.m. So, and if we could bring the audience questions to the front, that'd be fantastic. I'm going to introduce our panel moderator. His name is Kevin McKeegan in the center. He's the former chair of the Earth, Planetary, and Space Sciences Department. Kevin got his PhD at Washington University in St. Louis in physics. He's now a geochemist with broad interests and was recently awarded the J. Lawrence Smith Medal of the U.S. National Academy of Sciences, which is a great honor. He's also a fellow of the AGU, and he's going to lead our panel. So go ahead.
Thank you, Jean-Luc, and thank you, Dave, for a fascinating talk through history. I learned a lot. So here with me on our panel, just to my left, your right, is Dr. Paul Warren. Paul is a longtime planetary geochemist, member of the Institute of Geophysics and Planetary Physics and EPSS department, denizen of Slichter Hall, and one of the leading experts in the world regarding lunar petrology. So any questions about rocks on the moon, Paul's your man. All right? And just on the far side over there is Raquel Nuno. So Raquel is a fourth-year graduate student in EPSS studying processes associated with planetary surfaces. Raquel, before graduate school, worked for the Diviner mission and was also a blogger for the Lunar Reconnaissance Orbiter camera. And And in addition to looking for Raquel in the geology building, if you know how to do this, you can find her online at Instagram at The Space Geologist. And so she has a following much bigger than any of our classes. Thank you very much. And she can tell you all about that new world. And of course, Dave, you know. All right. So I thought we'd kick off our little discussion here with actually the oldest member of our panel, Paul. And since Dave gave us a little bit of a historical perspective, and many of us were alive when, 50 years, July 20th, that Armstrong and Aldrin set foot on the moon. And so I wanted to ask Paul how he recollects this historical event, and what kind of influence on your young developing mind and perhaps career you might have thought that, this presaged? Or, how did this influence you? How do you remember the event?
I remember Apollo 8.
Use the mic.
Yeah. I remember Apollo 8 maybe made more of an impression on me than Apollo 11. Apollo 8 was the first mission where they orbited in December of 1968. And that's where people first had this overview. And, I wasn't into science. I was 16. I was into 16-year-old stuff. And, to be honest, if you weren't into science yet, the samples when they first came back were a little disappointing. They were ordinary basalts. A lot of basalt on the Earth. It was a treasure of material, and it was just a down payment on much more to come with the other missions. But Apollo 8 was what really struck me, and my 8th grade science teacher, I think, steered me into geology, and then I happened to come to UCLA, right time, right place. And that's how I got into lunar stuff.
Okay, thanks. Now, Raquel.
Yes.
Okay, so some people weren't even alive when this happened.
I was
but
not.
nevertheless, you're extremely interested in lunar science. And so I wonder, for you, or if you can speak for other young people, what do you see as the legacy of Apollo in sort of shaping the worldview and getting you interested in planetary science? Or if maybe there's none.
Yeah, so as a legacy, as a planetary scientist, as a lunar scientist, to me it's really interesting to think about how there's this generation gap between people who are doing Apollo work, doing science with Apollo, and then there's this gap, a complete generation gap. If it wasn't for I think I have one here. If it wasn't for LRO, there would not be young people studying the moon right now. So I often think about that. That's if it wasn't for LRO, that all the expertise in Apollo, they're all dying off. So.
Not quite dead yet, thank you very much.
But the people who worked on the Apollo
That's
missions,
okay.
So that's the legacy to me is there's these precious knowledge and resources that we have that, if it wasn't for LRO, they would have been completely lost. So.
Okay. Now you work with you interact with a lot of young people who do a lot of science outreach. I mean, really young people. Okay, not that you're not really young, but what do you are people excited about the moon? Do people care about the moon? What?
So that's actually a really interesting question. I noticed that people are really excited, young people are really excited about space exploration. It's actually really hip right now to be into science and wearing NASA gear, NASA t-shirts. It's really cool. But then when you tell people about the moon, they're like, to the moon. We already know everything about the moon. We've been there. It's kind of boring. So something that I try to do with my own outreach is share my excitement about the moon, how much we actually still don't know. There's still so much to be discovered. And then people realize, oh, wow, really? We still don't know how it actually formed? So that's what I find, that it's they're excited about space exploration, they're excited about space, and NASA is cool, but we always see the moon up there, and I think it's often taken for granted that it's that it's something that we actually still need to research.
Yeah. Well, we heard a little bit about recent efforts with the Chinese space program, and I have a question here from the audience that I'd like to read regarding that. So the question is, how will the Chinese lunar exploration change the American space exploration, and will it re-energize the space competition?
Very interesting question. Well, in the past, first of all, the Chinese program is very deliberate. It is based on a long-term plan that they have, and since they have sort of the luxury of not having to worry too much about political or funding fluctuations, they can actually implement a long-term plan, space being just one of the types of plans that they have. So, you know, they have a plan where first we'll get some samples, then we'll explore the backside, we'll do this and that, and eventually it'll lead to human exploration and colonization and, you know, ultimate whatever. And that's just how they're approaching it, which I think is you need to do, really, if you're going to explore, you know, space and undertake such a massive undertaking effectively. When something will happen, I'm sure it will catch on that the Chinese are doing more than we did during Apollo, and that'll be an interesting situation. And the fact is, you know, their economy is doubling every 10 years, and it may not take too long before that time actually happens. Things in a situation where things are increasing very rapidly, people, you know, can't appreciate how fast things change.
Will it take, do you think, putting a person on the moon, planting a flag and reenacting what was done 50 years ago?
It could well be the case. And, you know, my experiences traveling to China is that they are all fanatical space fans over there. You know, if you're a Chinese astronaut, everyone knows who your name is. How many current astronauts can the people in this audience name?
Jessica Watkins.
Jessica Watkins, yeah, our UCLA grad.
UCLA grad from 2 years ago.
It's the only one I know about, right? You know, everybody knows who these people are. They're huge celebrities and things like that. So there's that, you know, excitement that maybe we had, you know, back in the day has definitely been kindled there. So, you know, I think it's a good thing. Exploration, any sort of, you know, knowledge gain, whatever is good. It's good for all of us. So, and all of us scientists are definitely, you know, 100% behind everything the Chinese are able to do on the moon.
Actually, you brought up in your talk, and we just sort of touched on it again right here about scientists and astronauts and so forth. And I wonder if Paul might want to speak a little bit about some of the relationships between scientists and astronauts going back to the days of Apollo.
Yeah, of course, this was before my time, but I do know Jack Schmitt fairly well, and I've interacted with a couple of the other astronauts. I think one thing to mention about this is that the missions were very different. Apollo 11, they spent very little time on the surface. They walked about 200 meters total or something. And then they were Apollo 12 and 14, they had a rickshaw on Apollo 14, and they managed to get like a half a kilometer or something in. The last three missions, they were able to really do geology. They went around, they covered 35 kilometers with the Lunar roving vehicle. And I think for that reason, the interaction between the scientists and the astronauts is much more for those latter missions. And of course, Schmitt was a trained geologist, so he's in a class by himself. But I reorganized meetings in the mid-'80s on the topics of the landing sites. And the Apollo 15 astronauts came to the meeting, and they were terrific. And the Apollo 14 astronauts did not come, and I always wondered about that. But more and more, they couldn't do much. They were just, there's a quote, I even wrote it down from one of them. They couldn't, he says, I couldn't tell you much about the rocks we picked up. We were in such a hurry. We had so little time without the lunar roving vehicle. It was all just grab, photograph, to document it, and go. So the missions are very different, and that's why the astronaut-scientist interactions would vary.
Okay, thanks. I've got another question from the audience, and I think This one is probably for Dave, but anybody could weigh in if they want. What is the point of going to Mars?
Well, we're going to Mars right now. We're on Mars. We're exploring it robotically. And I might say that, those of us that are involved in robotic exploration really do feel like we are doing it. It's not like some robot is doing my work for me. I'm doing it. I just happen to be, using a robotic vehicle to gain access to things I want to look at. So for me at least, robotic exploration is going there. And I see we did learn a lot. We learned a lot extra by having a human go into space and see the Earth and, react to the whole situation. So I think the point of going to Mars is we may discover something that we had no idea we were going to discover when we came up with the original plan, and therefore it may be worth doing. But if you want a cost-benefit relationship, it's not going to be there. But you also have to believe that there's more to life than eating, drinking, and sleeping as well. There's other things, and I think going to Mars is one of those other things.
Okay, and I can't resist the follow-on here quickly, which is, how did you use whatever you learned in Star Trek in your later work?
Well, it's funny. I actually worked with Roddenberry. He invited me to come and be the technical advisor for the Star Trek of the second generation, and he brought me in there. He said, "Hi, Dave.
Dave grew up in Hollywood.
Yeah. He drove me around the studio in a little golf cart. He explained the whole Star Trek universe to me, how he tried to set it up to imagine, how people might be in the future, and said how lucrative this has been for him because the amount of money they made in residuals was so huge that anything he put in there that might have dated the series could have really hurt him. So he thought, oh my God, imagine if I had Mr. Spock taking a drag on a cigarette in my show. I would have not made any money. That was his attitude. But now that I with the perspective of years, I can see that there was a manual they had for how to write a Star Trek script, and it was basically the Communist Manifesto. It basically described how everybody should behave and interact with each other in this universe, that if you were writing for it, you had to actually abide by. And I now see, sort of how these themes were sort of worked into this super popular show. It was so influential that it was just mind-opening going through this process, now seeing it later on in my life.
I never thought of Star Trek as subversive.
Well, it's not subversive. It's just presenting a particular point of view, and it's self-consistent.
Yeah, well, there you go. New view on history. Thank you. So, Raquel, tell us a little bit about your work with LROC, and what do you think is the coolest thing you've seen on the moon?
Oh man, the coolest thing I've seen on the moon. Caves. Lava
Caves are cool.
Did you guys know that there are caves on the moon? Yes.
Could be very important.
So check this out. I'll tell you how they form. So ancient lava flows. So on Mars there used to be lava flows, volcanic activity.
The moon.
On the moon. Yeah. And so at the top it hardens, it cools, and you have these lava flows that still flow, right? But the top is hard now. Now it's hard rock, and eventually there's no more lava to flow, and it drains. So now you have these tubes underneath the surface. And then what happens, you have a meteorite that comes in, it hits the surface, it punches a hole, and now you have a lava cave. And this is really exciting for human exploration of the moon. These are places that we can go and shield ourselves from the radiation and from the cold and from the heat. So I think that's the coolest thing that I've seen on the moon.
Okay.
Yeah.
Don't rest. I have another question for you from the
Okay.
audience.
Okay.
I am an 8-year-old astronomy and moon-loving girl.
Oh, yay.
I would like to do some real citizen science work. Can you use my help? We have a giant telescope, and I explore the 1,000,000 lunar craters.
Oh, that's so cool. Yes. Yeah, there's actually lots of, I can't remember the name of them, but come talk to me if you're still here.
Moonsu.
afterwards.
Moonsu.
Yeah, that's what it is, yes. So where people can actually get involved with doing actual space exploration and exploring the moon and actually do citizen science. And so yeah, there is opportunities to get involved, no matter what your age is.
Cool. So Dave finished up his talk with a nice big plug for Elon, who's going to rule the world. And you know, some people do think that before long, we'll maybe see hotels and maybe a Starbucks on the moon. So
Moonbucks.
Moonbucks, not Starbucks. Sorry. So
TM.
one quick question, show of hands. Who wants to go? Reasonable number. Okay. How much you willing to pay? No, that's another. But no, more serious question for anybody on the panel who wants to take this is, you know, as we enter this sort of new era where commercial and capitalist interests come to the fore and be able to explore the moon. So what kind of moon should we look for, and what kind of behavior or regulation, or how should the moon basically be managed? If anybody wants to take a stab at that.
Antarctica is sort of a predicate for this, but we need massive progress towards international agreement of how to share the moon.
Okay. Yep. So the idea would be that the moon would be shared in the way that the Antarctic continent, the only place that explorers went to previously without an indigenous population, has been managed by treaty fairly well. We'll see if that continues. That treaty's up for renewal in a few years, and so we'll see. Are you all there with Elon? Are you gonna?
No, I'm agnostic about it. I mean, I think it's important to highlight what the potential issues, might be back and forth. I think it would be nice if we could share everything, but that's.
We have an audience member who would like to make a comment.
Well, I might be one of the older guys in the room, but in 1962, I made the first Apollo reentry simulation while working on Apollo. In 1958, I was drinking coffee in the engineering lab when Sputnik came over and heard beeps all the time. And the emphasis on von Braun is way overdone. He was a rocket man. And the challenge to the moon was the most complex, most expensive endeavor with the highest risk ever attempted by the human race. There probably never will be equal again. And your economic figures kind of pointed out how much effort was spent on it. That time, in the 60s, the Russians were ahead of us.
Yeah.
They had a man in orbit.
Yeah.
They planted a vehicle on the moon. And it was a space race was a military motivated endeavor, although we did it tried to do it on the civilian side. But the dominance of the control of having our destiny possibly influenced heavily by the Russians was the primary motivation. When it was done, then it was kind of, gee, we did this wonderful thing, what do we do next? And all of the brains of the world worked on what could be done economically, politically, military, and they really couldn't come up with any good answer to justify continuing the kind of expenses that were involved in Apollo. But there's one very important thing that came out, and that is science. It is the platitude, it's the breadboard, it's the future of science. It's a whole area out there where scientists can have all kinds of fun. But until you find some economic justification, other than people doing a tourist trip, or find some political motivation, I think it'll stay in science, and that's a good place for it. Science is a good place for it. And you here are the ones that are going to tell what can be done. Joking about Elon Musk, he invented PayPal. Big deal. And he also smokes marijuana. So
Let's not hold that against him, all right?
Right. But I agree with you. The first person that's able to make money going to the moon will send us there very, very quickly, because as soon as you can invest and get back your investment, it's as good as done. It'll be impossible to hold back.
Yes, it'll take care of itself.
Yes.
And you scientists are probably going to find it.
Yes, that's our job.
It's not found yet.
Yes.
But something that we can see is that political competition is not sustainable. We saw once we got there, then that was it. It was over. There was no more interest anymore. But we see with the ISS, with the International Space Station, there is collaboration. There is cooperation between the countries, and that, to me, that looks like a really good model to sustain a scientific endeavor. You have to collaborate. I think that's the path that we have to get on. Not competition, because it's not sustainable, as we see from the Apollo example.
So let's wrap this up a little bit with science and talk a little bit more about the science. And since Paul is one of, really only 2 or 3 people in the world who know as much about moon rocks as this man sitting next to me, I want to ask, so now I put the pressure on you. All right, but what do you think are the most important things that we've learned from these samples? And should we be going back to get other samples for science?
Well, Dave mentioned the legacy, the gift that keeps on giving, the samples. Our technology is constantly improving, and we can go back to the same samples and learn all kinds of new things. But for the one thing that Dave spent so much on history, the science thing that I think I would leave you with that came from Apollo more than anything else is the chronology, the calibration of chronology throughout the solar system. With the lunar samples, we were able to place dates on craters on the moon. And the craters, the abundance of craters on a surface is reflective of its relative age. So we can get relative ages all around the solar system just from taking pictures of the surface. But to calibrate that, make it into an absolute age, it all depends on the moon, what we got from the Apollo samples. So that, I think, is the number one achievement. Well, it's among the top achievements, at least, of the Apollo legacy. Of course, we've learned so much about the moon, its evolution, composition, its interior. We've learned about the interaction between atmosphere-free surface and space, and like solar wind. We learned about a great deal from the moon, from the Apollo sampling. I don't know. I think that's
Okay,
it.
yeah. What about some of the science since Apollo? Raquel, where do you think some of this might be headed?
Oh,
Going to
in
be
the future?
driving, yeah. Or
I think a resource, looking for resources might be, I think, is the future of planetary exploration. As commercial interest becomes more important and actually drives a lot of the exploration, I think that's going to be something that is going to be the future, is looking for resources, where they are, what kind, how can we use them. Yeah, that's where I think the future's going.
Okay. Dave, you've been on the moon for 10 years now, so to speak.
Yes.
So what do you think? Where does it go from here?
Oh.
Do we need to do, so for example, in order to make significant progress on the moon, do you think it's important to send people? Can everything be done with robots and orbiters? This is the wrap up.
Well, the thing about people is interesting. People are relatively static in their capabilities over time. We're not much smarter than people that lived back in Roman times, not much more athletically capable, but machines have gradually and steadily evolved over time. And it's inevitable, I think, that especially given all the care and feeding that we need, that we're so perfectly evolved to be comfortable in this room here at UCLA with the oxygen and the chairs and the temperature and stuff like that. None of those comforts exist for us out in space. And so, I know that the the astronauts who went to the moon were very productive, the ones that had access to roving vehicles. But roving vehicles on the moon are very effective. There's not the big time delay like you have with Mars. And one could imagine remote controlling a rover and combined with VR technology and stuff like that. That Paul could maybe very soon sit in his lab and have a vehicle that's the Paul rover and just wander the moon.
It's a catchy title, Paul.
Okay, but I'm actually being serious about this. This is actually possible, technically. You would have your own rover. You could say hi to my rover. I'll, everybody go by you. You can say, I think there's some resources over there. We could both race each other or something. But seriously, I think that kind of a future where we each have our own, could have our own personal virtual presence on the moon and drive around like four-wheel drive RV vehicles. It's a very trafficable landscape. I think that kind of a future is a real possibility, independent of whether we're there ourselves.
All right. Well, we've heard some predictions, and I think we should just, as we close, keep in mind the great words of my favorite East Coast philosopher, Yogi Berra. Said, predictions are hard, especially about the future. So, thank you, Dave. Thank you, panelists. And